Hi students, before starting with the session, we will see what is colligative properties and some different formulas and different types of properties coming under colligative properties, right? So actually those properties of solutions which depends upon the number of solute particles and not on the chemical nature of the solute particles are called as the colligative properties. Actually there are four types of colligative properties. One is elevation of boiling point, and the next one is depression of freezing point, and next one is osmotic pressure, and another one is relative lowering of vapor pressure. So in this session we are going to see some numericals coming under elevation in boiling point. Okay, so before starting we'll see the formulas, right? So we used to express this elevation in boiling point with the term delta TB. Okay, so delta TB, how to calculate delta TB? See, if you know the boiling point of the solution and the boiling point of the pure solvent, it is possible to calculate delta TB. So before that, what is elevation in boiling point? Why it happens? See, actually when you are adding a non-volatile solvent, okay, so non-volatile solute, okay, non-volatile solute. What do you mean by non-volatile solute? Non-vaporizable. When this non-volatile solute is added to a pure solvent, okay, when it is added to a pure solvent, this non-volatile solute will occupy the surface of the pure solvent and it will lower the vapor pressure of this pure solvent. It will not, this non-volatile solvent will not allow this pure solvent to vaporize easily since it is occupying the surface, right? So automatically the vapor pressure of this pure solvent will decrease. So there will be a decrease in the vapor pressure of the pure solvent. So when you are automatically, when the pressure decreases, the boiling point increases. Okay, the boiling point increases. So when the pressure decreases, boiling point increases. There will be a hike in the boiling point of the solution after adding this solute. So when you are finding out the difference between the boiling point of the solution with that of the boiling point of the pure solvent, it is possible to calculate the elevation in boiling point. Okay, now we are representing the boiling point of the solution with the term Ts and boiling point of the pure solvent with TB. So delta TB is equal to Ts minus TB. Okay, this is one formula. Another formula is that delta TB is equal to Kb into 1000 into W2 by M2 into W1. What is Kb? Kb is ebullioscopic constant. Ebullioscopic constant. What is ebullioscopic constant? See, ebullioscopic constant is nothing but it is the elevation in boiling point when the molality of the solution is unity. When the molality of the solution is unity, is considered to be unity, then the elevation in boiling point is called as ebullioscopic constant. Okay, so by using this ebullioscopic constant also it's possible to calculate. What is W2? W2 is the weight of the solute and M2 is the weight, molecular weight of the solute, and W1 is the weight of the solvent. Okay, so now next formula is delta TB is equal to Kb into M. What is Kb? Ebullioscopic constant. What is M? It is molality. How to calculate molality? See, molality can be calculated from number of moles of the solute divided by weight of the solvent. Okay, how to calculate number of moles of the solute? See, number of moles of the solute can be calculated by using the weight of the solute and molecular weight of the solute. So weight by molecular weight will give the number of moles. Okay, so for molality of a solution, number of moles of the solute divided by weight of the solvent. Okay, if the weight of the solvent is given in kilograms, then no issues. If it is given in grams, then you should multiply this formula with 1000. Okay, so that's it, right? So these are the formulas. We'll see the problems now. Read the problem, students. The molar elevation constant for water is 0.47 degrees centigrade per kg of water. Calculate the boiling point of solution made by dissolving 5 grams of urea in 200 grams of water. Okay, so let us write the given data first. What are the data given? Kb, that is ebullioscopic constant, is given and it is 0.47 degrees centigrade, is it not? And then what else is given? The weight of the solute is also given, it is 5 grams. Okay, 5 grams, and weight of the solvent is also given, W1 is also given, it is 200 grams. Okay, and they are asking you to calculate the boiling point of the solution, that is they are asking you to calculate TS. See, if you want to calculate TS, you should know TB, is it not? TB you should know, TB you should know, and also delta TB you should know. Okay, so TB it is possible to know from the problem itself, because it is given water. It is per kg of water. Water is given. Water means water. What is the boiling point of water? It is 100 degrees centigrade. Okay, so it is 100 degrees centigrade. Now it is possible to calculate delta TB. How to calculate delta TB? See, delta TB, it's possible to calculate delta TB. Only if you know delta TB, it is possible to calculate TS. Okay, because the formula goes like this, right? Delta TB is equal to TS minus TB, is it not? Pure solvent. So we can calculate delta TB by using the formula delta TB is equal to Kb into M, because Kb is given, but we do not know what is M, is it not? So we should, now we are going to calculate the molality of the solution. Molality is equal to weight of the solute by molecular weight of the solute into 1000 divided by the weight of the solvent. Why we are multiplying with 1000? Because the weight of the water is given in grams. Okay, so we are multiplying. Now substitute all the values and find out the answer. 5, weight of the solute is 5 grams, and this molecular mass, it's given, is it not? What is the substance given? Urea. So molecular mass is 60. So 60 into 1000 divided by, what is W1? It is 200. So the molality is 0.41 m. Okay, now we can substitute the value of the molality in this formula. So delta TB is equal to 0.47, that is Kb value, into 0.41. So it is 0.192. Okay, now we can will substitute this value delta TB in this formula. So because we are in need of TS, we want to calculate TS. So we will substitute the value delta TB is equal to TS minus TB. So it is 0.192 is equal to what is TS minus TB, and we are in need of TS. So 0.192 plus 100, is it not? TB is 100. So the answer is 100.192 degree centigrade. Understood, students? We will see the next problem. Read the problem, students. A solution containing 13.6 grams of a non-volatile electrolyte substance in 186 grams of water gave boiling point of elevation of 0.75 K. Calculate the molar mass of the substance if Kb is 0.52 Kelvin kilogram per mole. See, in this problem they have given all the other data and they are asking you to calculate the molar mass. So you can substitute all the values in the formula to calculate the molar mass. Okay, so we'll write the given data first. See, weight of the solute is given, W2 is equal to 13.6 grams, is it not? And weight of the solvent, what is weight of solvent? It is 186 grams. 186 grams. Okay, and delta TB is also given, right? So delta TB is equal to 0.75. Okay, and then Kb is also given. Kb is equal to 0.52. Is it not? Kelvin kilogram per mole. So the unit is Kelvin kilogram per mole, and you are asked to calculate the molecular weight of the solute. Okay, so already we know the formula, right? So let us write the molecular formula. Molecular weight formula, M2 is equal to 1000 into Kb into W2 divided by W1 into delta TB. So all the values we are having, we can directly substitute the values and find out the answer. So 1000 into 0.52 into W2 it is 13.6 divided by, and what is the next value? What is W1 given? 186 into delta TB it is 0.75. Okay. So what is the see, we'll simplify this. It is 7072 divided by 139.5. So the answer is 50.69. So what is the unit for the molecular mass? It is gram per mole. Understood, students? We'll see the next problem. Solution containing 0.4216 grams of naphthalene. Its molecular mass is given 128.16 in 45 grams of CCl4, that is carbon tetrachloride, yields on boiling an elevation of 0.312 Kelvin. While a solution of 0.0616 grams of an unknown solute in the same mass of solvent gives a boiling point elevation of 0.543 Kelvin. Calculate the molar mass of the unknown solute. See, in this problem, two types of solutes are given. One is naphthalene and another one is unknown solute, and they have given all the data for naphthalene except what is that Kb, and they are asking you to calculate the molecular mass of the unknown solute. So this is a two-step process. So what you want to do is, in the first step you should calculate Kb using all the data of a known solute, that is naphthalene, and using that Kb you are supposed to calculate the molecular mass of the unknown solute. So this is the methodology. We will write the data given for step 1 first, that is for the known solute, that is naphthalene. Okay. So let us write weight of the naphthalene is 0.4216 grams and weight of the solvent given is 45 grams. Actually, in the second part of the problem also the same amount of solvent is used. Okay, same amount of solvent is used, and what else, the same solvent is also used. So we can make use of the Kb which is calculated in the first step in the second step also. Okay, so what else is given? Delta Tb is also given, that is 0.312 K. Okay, and then molecular mass is also given, it is 128.16. Okay, and what you want to do, you should calculate what else is, all the other data are given, and you want to calculate Kb. Kb, will calculate Kb because for the second step we are in need of Kb, right? So we will calculate Kb and we will make use of this Kb in the next step of the problem, right? So now we'll write the formula for problem. Formula, is it not? Molecular, for molecular mass, M2 is equal to 1000 into Kb into W2 divided by W1 into delta Tb. Now we can reshuffle this formula because we are in need of this Kb, is it not? So how to find out? Kb is equal to M2 into W1 into delta Tb divided by, what is the next one? 1000 into W2. Now substitute all the values, students. 128.16 into W1, what is W1? It is 45 into 0.312 divided by 1000 into 0.4216. Okay, so what's the answer? It is 4.26 Kelvin kilogram per mole. Okay, now we'll make use of this value, that is Kb value, in the next step. Okay, so we'll go for the next steps. In the second step we'll write the data given. What are the data given? See, it is W2 of this unknown solute, that is weight of the unknown solute is 0.6016. Okay, and the weight of the solvent, obviously it is the same, already it is given, the solute is dissolved in the same amount of the solvent, that is 45 grams. Okay, so what is delta Tb? Delta Tb given is 0.543 Kelvin. Okay, and then what is given? Molecular weight you want to calculate, is it not? And Kb, obviously we know, we are going to take it from this step. Okay, so write down the formula first. M2, we are in need of M2. M2 is equal to 1000 into Kb into W2 divided by W1 into delta TB. Okay. So, substitute all the values 1000 and what is KB? KB is 4.26, is it not? 4.26 into what is W2? 0.6016 divided by what is W1? It is 45 into delta TB 0.543. Okay. So, simplify this. 2562.8 divided by 24.43. Okay. So, the answer is 104.9. What is the unit for molecular mass? Gram per mole. You understood, students? Okay. Hope you might have understood all the problems. Before signing off, this is Sanita Raj. We will meet in the next session.